So in this video, we're going to look at how do we model an exponential function using real data and real numbers. The data that I've taken here is from Johns Hopkins, and it's the number of new cases of COVID-19 that are cropping up each day in Italy. So the outbreak there started on the 21st of February, and I'm recording this video on the 21st of March, so we have about a month worth of data here. So we're going to see what kind of relationship is there between time, so it's days going by, and the number of new cases that you're seeing every day. So this is not the number of total cases, but just the number of new cases that is appearing, which represents the spread of the virus. So what we'll do is we select the thing we want to plot. So we're going to want to plot the day number versus the number of new daily cases that we see each day. I've had to turn the days into just a numbered day so that it will work with a graph. Then you're going to want to go to Insert here, and you'll want to make a chart. And the type of chart we're going to make is a scatter plot, not a scatter plot with the lines connected, just a regular old scatter plot. So that kind right there. You can make it bigger, kind of stretch it out. Doesn't always do what I wanted to do, but there we go. That can make your chart a bit bigger. There we go. Good. Every graph should always have labeled axes. So that's the first thing you want to do. And you can find that under Add Chart Element here, where it says Axis Titles. You'll put a horizontal axis title on. And it's a bit finicky on a tablet for me here, but we'll put in a title here. So this is the number of days since February 20th, so starting on the 21st, that's 2020. So on the horizontal axis here, we just have time, number of days going by. You'll want to also add a vertical axis. So go again to Add Chart Elements and Axis Titles and do a primary vertical axis here. And you want to add a title here. So the vertical axis represents the number of new cases per day. So number of new daily cases is the vertical axis there. You can make these bigger font if they're a little bit small, and they are here. So you can select them, change the font to something a little more readable. Can select that and make the font a little bit bigger. There we go. So you can see it better. All right, to actually model this, you can see looking at the data, this kind of looks like an exponential curve, right? But we want to actually get an equation for that. And what's helpful about graphing something in Excel or Google Sheets, it's the same idea, is that the program will do the work for you of actually finding that equation and figuring out the best line of fit that fits this data. So all you have to do is click on your data, and what you're going to be adding is a trend line. Now, the type of trend line that would automatically be added is linear. That's not what we want. We actually want an exponential. So I'm going to go to More Options here. Make that trend line exponential, because you can see that's definitely not a linear relationship. It's growing exponentially. So we're going to use an exponential model there. And there's a few other things we want to do. Really importantly, we need to display the equation on the chart, because that lets the computer do the work for us of finding the exponential equation. We also want to display the R-squared value, which basically tells you how good of a fit you actually have for your data here. That's really all you need for your trend line. You can change fun things like its color and stuff like that if you want to, but you don't need to do that. So our trend line is on there. We've got our equation here. It always makes it really small, so it's kind of hard to read. So let's make the font a lot bigger. Hopefully that works there. There we go. Good. So there's our equation, a little bit more readable now. And so this equation, Y represents our vertical axis. So that's the number of new daily cases. And X is our horizontal axis, which represents time or the day. The R-squared value here, that tells you how good of a fit you have. An R-squared value of 0.94 or 0.995 is extremely high. This is a very, very good R-squared value. So the R-squared here is telling us, so r squared, you can add this to your notes, r squared tells us that the exponential curve is a very good fit to the data. So what that means is that this model is at least so far working. Now, hopefully, exponential models are not actually really what we want in any kind of viral outbreak, right? We would like to see that curve flatten. Is probably something you've heard a lot about. Exponential things grow really rapidly, so it's not a good thing. But you can see that that our data is so far following an exponential curve up to the day that I'm making this video, which is the 20th of March. What we can also do with data like this is make predictions for the future. So we can look ahead to some future day. Maybe we want to look ahead to April 1st, say, so the beginning of the next month, and see, well, where will this be at that future date? So if we do that, then we need to figure out first what day is April 1st. So to do that, you can kind of go over here. We need to know what day number we'd be on. So maybe I'll just delete this, I have some space. If you select sort of 2 days here, and then, oops, sorry. So you kind of select 2 days at once, and then you grab the little thing in the corner here, you can kind of drag it down. And it'll take you to a future day. So there's April 1st. And then if I want to know what day number that is, I can grab a few days here and it'll populate it all the way down. So that tells me that April 1st, if I want to know what this exponential model would predict for the number of new cases on April 1st, well, that would be day 41. That means that X here will be all the way over at 41. Let's see if we can sort out how many cases would we expect to see if this exponential curve isn't flattened and it just keeps growing up until April 1st. How many new cases would happen on April 1st? So our Y value is the number of new cases, and it's a function of time. So I'll use n for number of cases. And the equation is given to us here. So it's 44.71 e to the power of 0.1824, that's our growth constant, times the x value here, that's t, that's a time, right? And what I'm looking at is the number of new cases on April 1st, which is the 41st day. So I'm looking for n of 41 at the moment when t is equal to 41. So we're going to plug that in here. And we're going to solve for what that n would be. So first do the top of the exponent here, so 0.1824 times 41, then do e to the power of that, and then we multiply by the 44.71 out front. That gives me an astounding number of new cases. That actually gives me 79,110 new cases predicted on April 1st. So hopefully that does not come to pass. Hopefully by April 1st, Italy has things more under control, and the number of cases is, or number of new cases that they're seeing each day starts to drop off by then. But that's what this model would predict if an exponential curve continued all the way through.